Hello to everyone who's watching this video. We're Group 4 and this video shows you how to make a simple electric motor.
But before that, what is an electric motor? An electric motor is a device that converts electrical energy into mechanical energy. Most electric motors generate force in the form of torque applied in the motor's shaft by interacting between the magnetic field of the motor and electric current in a wire winding. Electric motors are extremely useful in modern life. To name a few uses, they are found in vacuum cleaners, dishwashers, computer printers, fax machines, video cassette recorders, machine tools, and etc.
There are 5 parts to an electric motor: the armature, stator, commutator, brushes, and the power supply. An armature is a continuous coil of wire that carries the current to and from a DC power supply. It is also called a rotor if it is the part that's rotating.
A stator or permanent magnet is the stationary part of a rotary system. In an electric motor, the stator provides a magnetic field that drives the rotating armature. In a generator, the stator converts the rotating magnetic field to electric current.
The commutator ensures that the current from the generator flows in only one direction. The purpose of the commutator on DC and most AC motors is to ensure that the current flowing to the rotor windings is also in the same direction and that the proper coil on the rotor is energized in relation to the field coils.
A brush is a small part of a motor that conducts electrical current between the motor's stationary wires, stator, and its rotating wires, rotor. The brush is typically composed of one or more carbon blocks, and it may include one or more shunts or terminals.
The power supply for a DC motor has to be a battery. This maintains the steady flow of a current in one direction.
In terms of construction, the motor and the generator are nearly identical, as both have a stator and a rotor. The main distinction is that a motor is an electric device that converts electrical energy into mechanical energy. The generator is the motor's inverse.
A generator converts mechanical energy to electrical energy, whereas a motor does the opposite. Both devices operate via electromagnetic induction, which occurs when a changing magnetic field induces a voltage.
Both motors and generators work due to a phenomenon known as electromagnetic induction. This is when a voltage is introduced by a changing magnetic field, as discovered by Michael Faraday. An electric current can be produced in a wire coil using electromagnetic induction by a moving magnet in or out of the coil, or by moving the coil through the magnetic field. Voltage is generated by motion in either case.
The amount of voltage induced is determined by the number of loops in the wire coil and the speed with which the magnet is moved through the coil. A greater number of coils induces a greater amount of voltage. Similarly, the higher the voltage, the faster the magnet moves through the coil.
What has this to do with motors and generators? A generator generates electricity by rotating a coil in a stationary magnetic field, whereas a motor spins a coil by passing a current through it. Faraday's law of electromagnetic induction is used in both cases, allowing you to generate electricity in your home and then use it to vacuum your floor, wash your dishes in the dishwasher, keep food fresh in your refrigerator, and do a variety of other things.
Remember how we said previously that a motor and a generator are the same device but produce opposing results? The flow of electricity is reversed, not the machine itself. So you can't just take a generator and turn it into a motor by reversing the machine's components. Similarly, you cannot produce electricity by simply flipping a switch that causes the components to operate in reverse. Instead, you must alter the direction in which the electricity flows, inward for a motor and outward for a generator.
In physics, circular motion is defined as moving an object around the circumference of a circle or rotating an object along a circular path. It can be uniform, a constant angular rate of rotation and speed, or non-uniform, variable rate of rotation. Circular motion is related to the motor in that the armature of the motor moves in a circular motion, resulting in a constant speed.
Since we have explained what an electric motor is, let us now build one. The materials that are needed to build an electric motor are enameled copper wire, neodymium magnets, 1.5 volt battery, office paper clips, and stationary knife.
The first step is to prepare the wire loop. So to do that, you take a thick enameled copper wire, then leave a few inches of wire and wrap it around an AA battery to form circular loops. Make around 12 to 15 loops and then cut the wire. Remove the battery carefully and then wrap both the loose ends of the wire on the loop at the opposite sides to form a coil.
The next step is making a coil holder. Take 2 office paper clips, then while using pliers, hold the clips in such a way that there is a hole at the center of the clip, as can be seen in the images above. Take a 1.5A high current battery. Using neodymium magnets, sandwich the clips to both the battery terminals. Place a strong magnet at the center of the battery. The holes in the clips will be used to hold the coil.
The last step is to insert the coil in the paper clips and give it a slight push. The coil will spin continuously till any external force is applied to stop it or if the battery dies. When the loop is placed on a metal conductor, such as a paper clip, current flows through it, creating a magnetic field around the coil. Due to the half enamel coating, there will be no contact when the loop rolls over, resulting in no current flow and no magnetic field. When another magnet is placed near the coil to interact with it, the coil spins indefinitely as the magnetic field around it tries to align with the magnetic field of the permanent magnet.
Our homemade electric motor is now ready. Thank you all for watching and God bless.